Hello, everyone. Have you ever seen your grandparents or maybe even your parents holding a newspaper really far away just so they can read the words? Well, that's often a sign of a common problem with our eyes. So today we are going to learn about two such defects of vision, hypermetropia and presbyopia. We will understand exactly what causes them and, of course, how we can correct them. So here's what we'll be covering today. First, we will introduce hypermetropia. Then, we'll look at its causes and how to correct it. After that, we'll move on to presbyopia, which is an age-related defect. I'll also give you some very important tips for solving numericals, for your exams. And finally, we'll summarize the key differences between the two. All right? Let's begin. Okay, so our first section, introducing hypermetropia. We're going to be understanding farsightedness. Now, to really get what this is all about, let's imagine a very simple, everyday situation. Okay, just picture this. You're sitting in your class, right? And you look out the window. You can see the school bus that's parked far away. Everything is perfectly sharp and clear. But then you look down at the textbook right in front of you on your desk, and suddenly all the words are blurry, fuzzy, and you just can't seem to focus on them. This is exactly what we're talking about. So what do you think this defect is called? Where distant things are clear, but nearby things are a complete blur. Exactly. This condition is called hypermetropia. Let's look at the definition. It's a defect where a person can see distant objects distinctly, but cannot see nearby objects clearly. And that's exactly why its common name is farsightedness. Makes sense, right? You can see far, but not near. So, what is happening inside the eye? Let's take a look. On the left, you see a normal eye. See how the light rays from a nearby object come in and focus perfectly on the retina? This gives you a nice, sharp image. But now look at the hypermetropic eye on the right. The light rays are not bending enough. They don't have enough converging power, so the image is actually formed behind the retina, and that is the reason for all the blurriness. All right, this naturally leads us to our next section, causes and correction. We need to understand why it happens, and of course, how we can fix it. Okay, so there are two main reasons this can happen. The first one is that the focal length of the eye lens is too long. Basically, the lens has become a little too thin, so it's not bending the light as much as it should. The second reason could be that the eyeball itself has become too small. This means the retina is now closer to the lens than it should be. But you see, in both these cases, whether the lens is too thin or the eyeball is too small, the main problem is the same. The eye lens simply has insufficient converging power. It's just not powerful enough to do its job properly. So, the big question is, if the eye doesn't have enough converging power, what can we do? How can we, add some more converging power to help it out? And the answer is a convex lens. Look at the diagram. A convex lens, as we know, is a converging lens. So what we do is we put it in front of the eye. It helps by bending the light rays a little bit before they even enter the eye. This gives our eye lens the little boost it needs to then focus the image perfectly onto the retina. It's like teamwork. Okay, let's move on to our next topic, presbyopia. This is an age-related defect. The key thing to remember here is that this happens as we get older. It's all about how the eye's power of accommodation, its ability to change focus, decreases over time. So what exactly is presbyopia? Well, it's when the power of accommodation of the eye decreases with age. And what does that do? It causes the near point, that's the closest you can hold something and still see it clearly, to gradually recede or move further away. This is why you see older people holding their books at arm's length. They're trying to find that new, farther near point. And why does this happen? Well, it's a natural part of aging. Two things happen inside our eyes. First, the ciliary muscles, which squeeze and relax the lens to change its focus, they gradually become weaker. And second, the eye lens itself isn't as flexible as it used to be. It becomes a bit more rigid. Now, things can get a little more complicated. Sometimes an older person can suffer from both myopia, which is nearsightedness, and hypermetropia, which is farsightedness. So imagine, they can't see distant things clearly, and they can't see nearby things clearly either. So how do we fix a problem like that? The solution is really smart. It's called a bifocal lens. Bi means two, right? So it's basically two lenses in one. The upper part of the lens is concave. That's to correct the myopia for seeing far away. And the lower part is convex. That's to correct the hypermetropia for close-up work, like reading a book.
Okay, everyone, listen carefully now. We're moving on to a very important section, tips for solving numericals. These are some points you must remember for your exams.
Here is the first and most important tip. When you get a numerical on hypermetropia, the one piece of information you must look for is the near point of the defective eye. This value is the key to solving the entire problem. And another thing to always remember, what lens do we use to correct hypermetropia? A convex lens. Correct. And for a convex lens, its power, which we call P, and its focal length, F, will always be positive. Please do not forget this sign convention. It is absolutely crucial for getting your answer right. All right, to finish up, let's quickly summarize the key differences. We'll put hypermetropia and presbyopia side by side to make sure everything is absolutely clear. Let's go through this table together. Look at the primary cause. For hypermetropia, it's a physical issue, like a short eyeball or a long focal length. But for presbyopia, it's about the ciliary muscles getting weak. Now, what about the typical onset? When does it start? Well, hypermetropia can be there from a young age. Presbyopia, however, is a problem of old age. And finally, the correction. Hypermetropia is corrected with a convex lens. For presbyopia, especially when a person has both defects, they will often need a bifocal lens. So I want you to remember this quote. The first step to solving any problem is to identify it correctly. This is so true for your numericals. Before you even think about formulas or calculations, you must first read the question and identify the defect correctly. Is it myopia? Is it hypermetropia? That is always step one.
And to end, I have a question for you to think about. Now that you know the difference between the two, why is a person with presbyopia more likely to need a bifocal lens than a young person who only has hypermetropia? Think about the causes we discussed. It's a great question to test your understanding. That's all for today. Thank you.